Hi everyone, my name is Charlene Faith de la Cruz, and I'll be discussing to you today about sieve analysis of aggregates, conforming the standard from ASTM and AASHTO. So today we're going to discuss about the introduction of sieve analysis, the test equipment needed, the general procedure, the data calculation, and the result and discussion. So what is sieve analysis? So sieve analysis is also known as gradation test. By definition, it is a laboratory test procedure that is an effective way of analyzing or determining the particle size distribution of coarse aggregate within a given sample. So sieve analysis is very important in every project. So why? What is the purpose of this? Since particle size can affect the strength of the concrete, the solubility of the mixture, and even the taste. So in sieve analysis, it can also provide the grade and the data. So we need the data later on, and I'll be discuss how to solve the following data. There are two methods of sieve analysis. First is the manual sieving method. Manual sieving method usually done on site or the places where there is no electricity. So the picture shown below is one of an example of manual sieving method. That picture, you should shake that 150 times, inclined about 1/6 of a revolution with intervals of 25 strokes. So that picture is just a handy manual sieving. So that's example. Next is the mechanical sieving method. So by definition, mechanical sieving method used in laboratories to assure the quality and is widely used method in present days. So today, since technology arises, we will gonna use mechanical sieving method. I don't know if it is present in our school, in the University of Mindanao, but today or later on, I'm gonna show you a video about mechanical sieving method. Mechanical sieving method can be classified into two groups. First is the horizontal movement sieving method, in circular motion. Second one is the vertical movement sieving method. It is a vibratory sieving method. There are two ways of sieving. The first one is the dry sieve analysis, and the second one is the wet sieve analysis. But let us discuss first what is dry sieve analysis. So, by definition, dry sieve analysis is a testing particles in dry state in which larger particles were tested, while wet sieve analysis is done after the dry sieve analysis to remove the particles smaller than 75 micron. 75 micron is the size of the opening of the last sieve in the mechanical sieving machine. So we're done about the introduction, and now let us proceed about the test equipment. So first equipment is the set of sieves or the series of sieves. So basically, sieve is a wire screen mesh having square openings. Of course, it has standard from ASTM E11. There are tables there that has a sieve number and corresponding sizes. So there are two groups of set of sieves for gravel fraction and sand fraction. For gravel fraction, set of sieves are larger than 4.75 mm, and for sand fraction is set of sieves that has smaller openings of 4.75 mm. So basically, in vernacular, so sa inato na tong istorya, sieves is ayagan. So here in sieve analysis, we're gonna use sets of ayagan. Next, we have pan, which you put under the set of sieves, the shovel, the weighing scale, in which very important in collecting data, mechanical sieve shaker, of course, and a wire brush to collect and to brush the set of sieves, the screens rather, and of course the aggregates. By definition, aggregates is a broad category, of course, the medium grain particulate material used in construction, including sand, gravel, crushed stone, slag, recycled concrete, and geocentric aggregates. There are two types of aggregates, the gravel fraction and the sand fraction. So gravel fraction are particle size bigger than 4.75 mm, and sand fraction which is smaller than 4.75 mm. So let us proceed to general procedure. First is sample. So find the sample that aggregate perform as intended for the specified use. Make sure there are no foreign objects in the sample. Next is collect. In collecting the sample, sometimes we will use quartering. So quartering is a method of collecting aggregates. That was discussed last week. Next is transport. So transport the sample safely to the laboratory. Next is prepare. So in preparing the sample, make sure you will dry the sample by using the mechanical oven under 100 degrees Celsius to 110 degrees Celsius. Last one is the test. So there are another following steps under the test procedure. So experimental procedure is the procedures that under the test, the last step in general procedure. So here we need to weigh the sample in desired mass, prepare the set of sieves from larger to smallest openings, put the sample on the top of the sieves and cover, sieve the sample by using the mechanical sieve shaker, weigh and calculate the data.
A sieve analysis or gradation test determines the distribution of aggregate particles by size. This information can then be used to determine if the material will comply with design and production requirements. A dry representative sample of material is weighed and then is placed in the top of a group of nested sieves or screen trays, arranged in descending order from the largest openings at the top to the smallest at the bottom. The stack is agitated manually or using a sieve shaker for a designated period of time, and the operator weighs the material retained on each sieve using one of two methods.
So, next, let us proceed to the data and calculation. There are a set of steps that we need to follow in calculating the data. The first one is weigh the sample in each sieve to get the total mass. Next, calculate the percent retained on each sieve. So the formula for percent retained is the mass of the soil retained in each sieve over or divided by the total mass of the soil times 100. So later on, we're gonna visualize this formula because I have an example problem. So today, let us just wrap up. Number 3, calculate the weighed sample. So there are two methods of calculating the weighed sample. The first one is the cumulative method. So its formula is flashed on the screen. So for cumulative percent retained, we have this cumulative mass over the total mass times 100. For cumulative retained passing, the formula is 100 minus the cumulative percent retained. So cumulative method, so let me read the definition. So cumulative method where each sieve fraction beginning with the coarsest is placed in a previously tiered pan and weighed. So this process is repeated until all fractions and the bottom pan have been added and weighed. This is a good time-saving option since you don't have to empty the pan on the scale. So bali, kung magtimbang ta sa sample, atong ipunon lang dito sa pan. Kung tahay na ni siya weighing scale, then pan, iipon lang ang mga sample, then timbangon. Muna siya ang process sa cumulative method. While in fractional method, its formula is 4% fractional retained, fractional mass on each sieves divided by total mass times 100. For fractional passing or fractional percent passing is percent of fractional retained minus percent of retained on the sieve below. So, in fractional method, operator weighs the content of each sieve separately. So kung magtimbang ka, for example, sieve number 4, timbangon nimo, then empty the pan, timbangon na po nimo ang sieve number 10. So yun na siya dili kinahanglan empty ang pan anyway. Samantala sa cumulative, ipunon lang ang kada set of sieves. So next, number 4. Calculate the percent finer. So percent finer is the percentage amount of the soil which is finer than a particular sieve. So its formula is 100 minus cumulative percent retained. So next, kindly take note for those formula because we will gonna use that later on. So next is number 5. Draw the distribution curve. So later on, I'm gonna show you an example of a distribution curve. Next, the last one is to calculate the uniformity coefficient and coefficient gradation. So now, let us calculate or let us solve the sample problem and make sure you are with your best friend. Your calculator is with you. So, in the screen below, in the screen above, it is the sample problem from the same. So here, step 1. So what is the step 1? Step 1 is to weigh the sample in each sieve to get the total mass. So in that table, step 1 is the mass of the soil retained on each sieve. So kung makabantay ta, sieve number 4, 0. Sieve number 10, 40. Iyahang mass, which is in grams. So on and so forth. Iyahang total mass diriya is the 729. So now, manata, nakasabot na ta sa step 1. For step 2, calculate the percent retained on each sieve. So how we calculate the percent retained on each sieve? The formula is the mass of the soil retained on each sieve divided by the total mass times 100. So for example, since naa na may answer dira, so we need also to calculate for clarification and for accuracy. For example, in sieve number 10, naatay timbang 40. 40 divided by the 729, which is the total mass, times 100. Okay, so the answer is 5.4869. So here, na-round off na siya, mo na siyang 5.49. So, next, mo na siya ang kining illustration kung saan na to pagkuha sa percent retained on each sieve. So, step 1, step 2, check. Let us proceed to step 3. What is the step 3? Choose the method of weighing the sample, which is cumulative ba or fractional. Since atong data, ang example sa atong data is cumulative atong gamiton. Kung sa itong formula sa cumulative, the cumulative mass over the total mass times 100. Okay. So in step 3, mano na 0.49, 13.72 man na diha. So, ato siyang i-plus. So, for cumulative, so si sieve number 4, ang iyahang cumulative percent is 0 since iyahang mass kay 0. So, kung ato siyang i-solve, 0 man iyang mass, 0 divided by 729 times 100, answer is 0. So, in sieve number 10, naa siya yung mass nga 40. So, sa sieve number 4, na may 0 plus 40 divided by 729 times 100, mo na siyang answer is 5.49. Mo to siya, so on and so forth in ato ang steps pag-solve sa cumulative percent retained on each sieve. Pero na ako'y itudlo nga shortcut. So, ato ni siyang i-indicate nga kining percent retained sa 4 is P1. So, nano siya sa screen. So, ato na siyang P1 as is nato dito sa cumulative percentage is 0. Para makuha nato ang cumulative percent retained ni sieve number 10, ato orang i-add ang percent retained ni 4 o ni 10, which is 5.49. Sunod, ato na po, para makuha na po nato ang cumulative percent retained ni sieve number 20, atong plus lang ang percent retained ni 4, ni 10, o ni 20. So, 0 plus 5.49 plus 8.23. Na siya answer na 13.72. So, same lang sila og answer kung formula itong gamiton o kining P1 plus P2 plus P3 plus P1 plus P2 plus P3 plus P4. Kaya kung makasave taani og time, labi na kong exam. So, I hope na nasabtan ninyo on saan pagkuha ang cumulative percent retained on each sieve. Next, let's proceed to step number 4. So, step number 4 is the percent finer. Kining percent finer, gina-calculate kung pila ka percent ang mas pino ani niya. So, diri sa step number 4, ay sa sieve number 10, pila ka percent ang mas pino sa step number 10 na atay 94.51. So, dali ra kayong kuan. Step number 4, as long as tama ang atong cumulative percent retained. So, kaya ang formula man sa percent finer is 100 minus cumulative percent retained on each sieve. So, 100 minus 5.49, ang answer, 94.51. Next, ang step number 5 is draw the graph or the distribution curve. So, unsa na to pag-draw sa distribution curve? Kinahanglan nato ang number of sieves, sieve number, o ang percent finer. Mo na siya ang pag-draw sa graph. Ang x-axis mo ang sieve number or sieve particles or particle diameter. So, kung tahay, diri sa kuan, sieve number 4, ang particle diameter na niya is 4.75. So, asa man ko nanguhaan ng nga kuan diameter. So, nana siya sa standard. Kung i-research ninyo number of sieves and its sizes, makita ninyo dito kung unsa ni nga sizes ang kada sieve, number 10, number 20. So, let's proceed na akay graph diri ang akong gibutangan o particle diameter. So, sa sieve number 4 na ay 4.75, sa sieve number 10 na ay 2 mm, sa sieve number 20 na ay 0.84, so on and so forth. Samantalang diri sa pikas, mo ni siya ang atong y-axis, mo ni siya ang percent finer. So kung tanaw na to sa table before, sa 0, iyang percent finer is 100. So diri po 4.75, natunong po siya sa 100. Ang sieve number 10 na siya particle nga 2 mm, iyang percent finer is 94.51. So, nadiri apod, 94.51, diri po siya tama. So, mo ni siya. Pagkahuman ani sa pag-draw na to sa distribution curve, atong kwaon si D10, D30, o si D60. Kini sila atong magamit later on sa pag-solve na to si uniformity coefficient o coefficient of gradation. So, nadiri sa graph, mo ni siya ang D10 na belong siya sa 0.5 mm. Samantalang si D30 na siya value nga 0.17 mm. Nya si D60 na siya value nga 0.28 mm. So, I hope dali raman ni mag-plot sa distribution curve since naaman siya basta ito hinumduman lang nga ang y-axis is the particle size which is found in the sieve number na siya corresponding sizes. Kindly search o napo na siya sa written report. So makita niyo ang table dito Next, sa y-axis mo ang percent finer. So mo na lang siya atong i-plot. So, naata to sa last part. Calculate the uniformity coefficient. So, how to calculate the uniformity coefficient? It has a formula of D60 over D10. So, naadiriya ang value ni D60. Ang value ni D60 is 0.28 over D10, 0.15. So, ang answer is 1.86 or round off 1.9. So, note, uniformly graded soil has identical particles with CU value approximately equal to 1. So, kung uniformly graded soil, ang pasabot ana is almost same size ang particles ana nga sample. Samantalang uniformity coefficient value of 2 or 3 classifies the soil as poorly graded or uniformly graded. So kung naadiri sa 2 to 3, ang answer aning uniformity coefficient, naa siya sa poorly or uniformly, same sizes, jud na sila pareho. So next, so therefore, since 1.9 man ang answer sa tong problem, nabilong siya sa uniformly graded or poorly graded sample. Next, let us solve the coefficient of gradation. Coefficient of gradation na siya ay formula nga D30 squared all over D10 times D60. So, ang atong D30 kay 0.17 mm squared over 0.28 mm times 0.15. So, ang answer is 0.69. So, another note, if the value of this coefficient is less than 1, then the soil sample is poorly graded. And if the value is between 1 and 3, implying a steep curve, then it is considered as well graded. So kay less than 1 man ang ato ang results sa sample, therefore we can conclude nga uniformly graded and poorly graded ang sample. So nag-coincide si uniformity coefficient o si coefficient of gradation. So, next slide, mo ni sila ang example sa graph nga nagpasabot nga uniformly graded. So, kung tanawon na to diri same gyud ang ato ang graph diri sa koan. Well graded kung paslant gyud siya to. Gap graded kung pa curve. So, na diri sa second picture, mo ni siya nagpasabot nga well graded. Naa tanan particles, set of particles gikan sa dako to gamay. Kini uniformly graded, which is mo ang answer sa tong data ganina, almost the same size sila tanan, pantay-pantay. Samantalang ang gap graded naay dagko tapos ni kalitra gamay. So mo na siya ang gap graded, mo na siya ang illustration sa sample. Next, ato ta sa result and discussion. So, to sum up the sample problem, based on the calculation done and the data presented in the table, we can conclude that the sample is poorly graded or uniformly graded. It is not advisable to use in concrete mixture, for it requires excessive amount of cement to fill the voids and making them uneconomical. So pasabot, kung poorly graded ang ato ang aggregates, mas kala siya semento, mas gasto kay since atong ginaapas ang katong mga voids, mga fill-in. So naidag ko yung kalitra gamay, pangit pod ang gap. So kinahanglan ang ato ang aggregates is well graded. So katong set of sieves kompleto. To encapsulate, sieve analysis is important before buying and using the aggregates for every construction to expect better results. So, supposedly the standard before making project is you need to undergo the sieve analysis to know and that the aggregates or the sample is well graded. Para dili ma-short ang atong budget kung sa semento ba, kung kay kasagaran, graba na ay mas daghag balas kaysa sa bato, mas daghag bato kaysa sa balas. So, kailangan pantay ang bato ug balaso. Sieve analysis is very important. So, if you have any questions, kindly comment or kindly reply on that in the forum in the LMS. So that's all. I hope you understand the sieve analysis method, and thank you and God bless.